All right, in this section I'm going to cover how to construct the confidence interval for a population proportion and how to interpret it as well. So let's first start off with doing a point estimate for a population proportion. So here's a core example. So suppose 935 smokers each received a nicotine patch. And this nicotine patch essentially delivers nicotine to the bloodstream, but at a much slower rate than cigarettes do. So let's say that we gave these smokers a dosage and then we decreased it to 0 over a 12-week period. So of these 935 smokers, 245 were still not smoking after 6 months, smoking 6 months after the treatment. So the dosage is that they decreased it to 0 over a 12-week period. So that's the treatment that they received. Then at the end of this 12-week period where we measured if they were still smoking or not 6 months after this. So using the given information to estimate the proportion of all smokers who, when given this treatment, would refrain from smoking for at least 6 months. So in this sentence, the proportion of all smokers who, when given this treatment, would refrain from smoking, from that bracket to this bracket, that's what P would be, right? And that thing is unknown, correct? We're trying to approximate that that value, that proportion. So it's almost like what percentage of smokers can kind of go 6 months after this treatment still not smoking. So our P hat is our best estimate. So use the given information to estimate it. Well, we did a sample of 935 people, right? 245 of them still weren't smoking after 6 months. So we would do 245 divided by 935, and that gives me 0.262. So that is our point estimate for P. Now, every sample would be different, right? If I took another a different size sample, maybe a different 935 people, right? My proportion would change. That's called sampling variability. So for every point estimate, right, there is a standard error associated with this. That standard error typically is given by the standard deviation, right, of the sampling distribution, but we don't know what P is, so we can't calculate this. So we're going to estimate it, right, with P hat, and that's what we call the standard error. So I'm going to plug P hat into this formula. It's 0.262. So I'll do the square root of 0.262 times 1 minus 0.262 all over 935. So in my calculator, I would literally, here, I'll show you. So you do the square root of 0.262 times 1 minus 0.262 and close parenthesis divided by 935 and parenthesis 0.014. So this is the standard error. So that essentially means this sample proportion, it's reasonable to think it's off by about 1.4%. Now we would, this is a point estimate and standard error. We may use this thing called the margin of error, right, to construct an interval estimate. So we can find the margin of error for 95% confidence by taking 95%. We know that the critical z-score associated with that is 1.96. And so the margin of error is determined by z sub c times, right, the standard error. So we're calling the margin of error here E. So I would take 1.96 and multiply that point by 0.014. And so our margin of error would be exactly 0.027. So to interpret this, this would be the error needed, or the margin needed, right, to capture 95% of the P hats that would reflect essentially where P hat lies. So this is kind of how far off we need to go from our point estimate, right, in either direction, about 2.7 in either direction, to kind of get a better idea of where the true P would lie. Okay, so let's actually do an example here where we actually construct this confidence interval. So Let's say an article included data from a survey of 2,667 hiring managers and human employers are now using social networks to screen job applicants. Of the 2,667 people who participated, 1,200 indicated that they use social networking to research job applicants. Construct and interpret a 95% confidence interval for the true proportion of hiring managers that use social networks to research job applicants. Okay, so again, from here to here, that's the thing P, which is unknown, right? I want to know what proportion of hiring managers or employers, right, use social networking to research job applicants. So, of the 2,667 people who participated, 1,200 said they do use social networking. So my P hat, or my point estimate, would be 1,200 over 2,667, which is I'm going to round that to 0.45. So about 45% of employers use that. So that's my point estimate. Let's find the standard error. We know that that's approximately equal to the square root of P hat times 1 minus P hat over N. So this is 0.45. 1 minus 0.45 would be 0.55 divided by 2,667. So I calculate that. I get 0.009, so I'll round that up to about 1%, 0.01. Now, my margin of error, so this is the standard error. So my margin of error is Z sub C times sigma sub P hat. And here, since I'm using 95%, right, that means Z sub C is 1.96. So we get 1.96 times 0.01, which gives me essentially 0.02. Okay? So my confidence interval would be exactly this. I take P hat and I add and subtract off the margin of error. So I get 0.45 plus or minus 0.02, which gives me the interval 0.43 to 0.47. So this is my 95% confidence interval. And so to interpret this, we could say, right, the true proportion of employers that use social networks to research applicants is contained between 43% and 47% with 95% confidence. Okay? So less than half. We're pretty confident that less than half of employers use social networks. Let's do one more example. Okay, so the mechanics are kind of the same. So let's just put some different numbers to it. So an article summarized data from a survey of 1,001 mothers with children under the age of 2. The article includes the following statement. 83% of moms post new baby photos from the delivery room. Construct and interpret a 99% confidence interval for the proportion of mothers of children under the age of 2 who post pictures of their new baby on social media. So again, this is P, which is unknown. P hat is 0.83 because the article is using a sample of 1,001 mothers. Now, see, it's kind of misleading that they just go ahead and say, oh, the article includes the following. 83% of moms post it, right? I mean, that's their 83% of their sample. So they didn't really conduct a confidence interval, right, to give you a range of numbers. They just took their sample to be representative of the whole population, which is kind of not what you should be doing. But anyway, we can still say that, right, P hat is 0.83. Our sample size is 1,001. Now, one thing I forgot to do in the previous example is to make sure the normality condition holds, right? So N times P hat, which would be 1,001 times 0.83, these two things better be bigger than 10. Our sample is pretty big, so I'm sure it is, but let's just do a quick check here. So 1001 times 0.83, so that's 830, that's definitely greater than 10, and 1001 times 0.17, so that's 170, which is definitely greater than or equal to 10. So it checks out. Our sample is big enough. Okay, so here's the point estimate again that was given. And here, let me just do it a different way. I'll just jump to the punchline here. So this is my confidence interval. But if I put all the components in, what I'm really doing is taking z sub c, right, times the standard error, which is this. Okay, so if I want 99% confidence, that means z sub c is 2.58, so it's a little bit bigger. So here I'll take 0.83 plus or minus 2.58, right, times the square root of 0.83 times 0.17, all over 1001. Okay, so when conducting this confidence interval here, first compute the margin of error, the stuff on the right. So I'll do 2.58 times the square root of 0.83 times 0.17 divided by 1001. So my margin of error is 0.031. And so my interval would be 0.83 minus 0.031. So this is my left-hand point, and 0.83 plus 0.031, 0.861. So we are 99% confident that the true proportion of mothers who post new baby photos, I'll just write baby pics, from the delivery room is contained between 79.9% and 86.1%. Okay? So that's how you find a confidence interval.